Researchers at MIT and Texas Instruments have developed a new type of radio frequency identification, that is RFID chip, that is virtually impossible to hack. If such chips were widely adopted, it could mean that an identity thief couldn't steal your credit card number or key card information by sitting next to you at a cafe. And high-tech burglars couldn't swipe expensive goods from a warehouse and replace them with dummy tags. Texas Instruments has built several prototypes of the new chip to the researchers' specifications. And in experiments, the chips have behaved as expected. The researchers presented their research this week at the International Solid-State Circuits Conference in San Francisco. The chip is designed to prevent so-called side-channel attacks. Side-channel attacks analyze patterns of memory access or fluctuations in power usage when a device is performing a cryptographic operation in order to extract its cryptographic key. One way to prevent side-channel attacks is to regularly change secret keys. In that case, the RFID chip would run a random number generator that would spit out a new secret key after each transaction. A central server would run the same generator, and every time an RFID scanner queried the tag, it would relay the results to the server to see if the current key was valid. Such a system would still, however, be vulnerable to a power glitch attack, in which the RFID chip's power would be repeatedly cut right before it changed its secret key. An attacker could then run the same side channel attack thousands of times with the same key. Power glitch attacks have been used to avoid limits on the number of incorrect password entries in password-protected devices. But RFID tags are particularly vulnerable to them since they are charged by tag readers and have no onboard power supplies. Two design innovations allow the MIT researchers' chip to prevent power glitch attacks. One is an on-chip power supply whose connection to the chip circuitry would be virtually impossible to cut. And the other is a set of non-volatile memory cells that can store whatever data the chip is working on when it begins to lose power. For both of these features, the researchers use a special type of material known as ferroelectric crystals. Because the chip has to charge capacitors and complete computations every time it powers on, it is somewhat slower than conventional RFID chips. But in tests, the researchers found that they could get readouts from their chips at a rate of 30 per second, which should be more than fast enough for most RFID applications. This research is an important step toward the goal of a robust, low-cost, low-power authentication protocol for the industrial internet.